Today I'll be teaching you how to look for the MGF as the moment generating function of a normal distribution. We know that the f of x of a normal distribution is 1 over sigma square root of 2 pi e raised to the power minus half x minus mu over sigma square, where x is going from minus infinity to infinity, mu is going from minus infinity to infinity, and sigma square is greater than 0. In my previous video, I showed you that the expected value of x is mu. So now I want to show you how to solve for the MGF as the moment generating function of a normal distribution. So MGF of x, and x follows a normal distribution with mean mu and variance sigma square. So we use this function to represent this notation to represent the MGF, and is equal to expected value of E T x. And this is equal to the integral from minus infinity to infinity E T x times f of x dx. So what is the f of x? So I have to substitute the f of x. So I have E T x times 1 all over sigma square root of 2 pi e raised to the power minus half x minus mu over sigma all square dx. To simplify this, I have to take all the constants that do not have anything to do with x outside. So look at this, it does not have anything to do with x, so I can take it outside. So I have 1 all over sigma square root of 2 pi minus infinity to infinity e tx minus half x minus mu over sigma square dx. To simplify this, I have to apply the law of indices. No, I've already applied the law of indices, so that's what I did. So I had e raised by tx and e raised by minus half. So the law of indices, I used it combine both. So that's why I have e tx minus half or bracket x minus mu sigma square. Simplifying this, I will have e tx. So let me factor out minus half sigma square. If I factor out minus half sigma square, what will remain from the left hand from the second function will be x minus mu square. I factored out 2, and I factored out sigma square, so this sigma r square. I want to do the same to the first function, which is this. I'm factoring out 1 all over 2 sigma square because I don't have 2 sigma square here, then I have to multiply it to the first function. So I will have minus 2 sigma square tx. So that's how it works. So let me explain what I did here. So if I have a function like this, x over 2 plus y, and I want to factor out 1 all over 2. If I factor out 1 over 2 from the first function, x will remain. Now for the second function, because I don't have divided by 2, I don't have over 2, I will have to multiply by 2 to y. Now the reason why I'm multiplying by 2 is so that if I try to expand, if I want to expand this bracket, I will have x all over 2. Half times this will give me 2y all over 2, so that this will cancel this, 2 will cancel 2, and I will be left with x over 2 plus y, which is my original equation. So that's what I just did. So back to what I was solving. We'll have 1 over sigma square root of 2 pi minus infinity e raised to the power minus half sigma square. So if I expand x minus mu all square, I will have x square minus 2x mu plus mu square minus 2 sigma square tx. Uh, 1 over sigma square root of 2 pi minus infinity infinity e raised to power minus half sigma square x square. I can factor out. So look at this. I have minus 2x here. I have minus 2x here. So I can factor out minus 2x. I'll have minus 2x. I will have mu remaining plus, if I factor out minus 2x, I will have sigma square t remaining and plus mu square. Oh, I skipped the x here, the x, the x, the x. I can apply what we call completing the square. So applying completing the square method. Let me explain briefly let me call this equation 1. I want to explain briefly what I mean by completing the square. So we use completing the square to factorize. So if I have equation like this, x squared plus 6x, and I want to apply completing the square method. So what will I do? The first step, you have to make, so this is like a quadratic equation. Your a must be 1. The quadratic equation is like this: ax squared plus bx plus c. A is the coefficient of x squared, b is the coefficient of x, and c is the constant. Comparing these two equations, my a is 1, my b is 6, and my c is 0. So just like I have plus 0 here. So first, the coefficient of x squared, which is a, must be 1. Then the next step, you divide b by 2. So that is divide 6 by 2. Then you square it. After doing that, you go back to the initial equation, which is x squared plus 6x. You add this factor you just have now, which is 6 over 2 will give me, that's 3 squared. So you add 3 squared and also subtract 3 squared. Looking at this, I didn't do anything to the equation because 3 squared minus 3 squared will give me 0. So I will still get back the original equation. So this is how we do completing the square. Then you consider this. When you consider that, you pick the first by the first object here, which is x. You pick the next one here, which is plus 3, all square. So now so all this means this. Then what is remaining? Minus 3 squared. So this is how we use the completing the square method. One thing you should know about completing the square, it helps you to factor out x. So looking at this, we add x appearing times, but after completing the square, x is appearing just once. Now I want to use the same technique in our equation 1. So let me write out equation 1 again. So our equation 1, we have let me just clean this. So I just explained completing the square. Now I want to apply completing the square to our original equation. So I will have 1, 1 over sigma square root of 2 pi minus infinity, e raised to power minus half sigma square x square minus 2x. I'm just repeating what we have above plus mu square dx. Okay, so continue from where we stopped. Let's consider just the power of the exponent, or consider what we have in the bracket. So let me consider what we have in the bracket. So this is what we have in the bracket: x squared minus 2x, x minus mu. I will come back. Mu. So we have mu plus sigma squared t plus mu square. So applying completing the square method, my a is 1, my b is minus 2 mu plus sigma squared t. Remember, what is b is what is outside the coefficient of x. Then my c is mu square. Y c is the constant that has nothing to do with x. Completing the square method, you divide b by 2. So I'll divide minus 2 mu plus sigma squared t all divided by 2, which will give me minus mu plus sigma squared t. Then the next step, you take b all over 2 square, which is minus mu plus sigma squared t all raised to power 2. Then I will substitute back to my equation. So let me call this 3, equation 3. So substitute back to equation 3. I will have x squared minus, so what I will do, I will add, remember the technique, you add this factor we have there, you add it to your equation that you want to apply completing the square. You add and subtract. So I will add it. So I will add it and subtract it. Minus mu plus sigma squared t all square. I've added this, I will subtract it. Minus mu plus sigma square t. Then I have plus mu square. Plus mu square is this. Remember what I did? You pick this without the square. You pick everything here without the square, including its sign. All raised to power 2. So that's how it is. You ignore this. You pick this without the square. You pick this without the square, and everything will be all square. Then we have minus mu plus sigma squared t square. Then we have here plus mu square, which is equal to x. If I expand this bracket, I'll have minus mu minus sigma squared t all square. Because of this square, I will have square will cancel out the negative sign. I will have mu plus sigma squared t square plus mu square. If I expand the second bracket, that has nothing to do with x. If I expand it, I will have mu square plus 2 mu sigma squared t plus sigma squared t all square plus mu square. So this will give me x minus mu minus sigma squared t all square minus mu square. So I'm using this negative sign. I'm using this negative sign to multiply everything. Minus 2 mu sigma squared t, and minus sigma to be sigma 4 t squared because of this square, then plus mu square. So plus mu square, we cancel out minus mu square. So I will have x minus mu minus sigma squared t squared minus 2 mu sigma squared t minus sigma 4 t squared. Remember, I factored, I took back to this. I considered only what we have in the bracket. So I want to, so let me call this equation. This is already equation 1. I called it equation 1. Yeah. So now I have to substitute back to equation 1. So substituting back to equation 1. So this is what we have in equation 1. So I have 1 all over sigma square root of 2 pi integral minus infinity to infinity. Then we have e raised to power minus half sigma square. Then all we have in the bracket is now x minus mu minus sigma squared t all square minus 2 mu sigma squared t minus sigma 4 t square. Dx. Now, remember, because I'm integrating with respect to x, I can take out all the constant that has nothing to do with s. I can take them outside the integral sign. So first, let me simplify this using my law of indices. So using law of indices, I will multiply. I will use the exponent to multiply what we have in the bracket. So I have 1 over 2 sigma square times x minus mu minus sigma squared t all raised to 2 and times e minus half sigma square all multiplying minus 2 mu sigma squared t minus sigma 4 t square dx. So taking the constant outside, I will have e, and also I want to factor out minus 2 sigma square. So if I factor out minus 2 sigma square, or let me expand, let me multiply it. So I have minus 2 mu. So this is what I'm doing. I'm looking at this equation now. I'm taking it out of the integral sign because it has nothing to do with x. So I have minus 2 mu sigma squared t all divided by minus 2 sigma square. And I also have minus sigma 4 t square all divided by minus 2 sigma square. Okay, I have 1 all over sigma square root of 2 pi, which is this. Then integral minus infinity to infinity, e raised to power minus x minus mu minus sigma squared t square all over 2 sigma dx. So this is what I have. This will cancel out this. Sigma square will cancel out sigma square. I'll be left with mu t. If I do the same, let me change the color. If I do the same to this, sigma square will cancel out. Sigma square will cancel sigma 4. I'll be left with sigma square. So what the minus will cancel minus. I'll have plus sigma square t square all over 2. This minus will cancel this minus, giving me plus. Then I have times 1 all over sigma square root of 2 pi minus infinity to infinity, e raised to power minus x minus mu minus sigma squared t square all over 2 sigma dx. To simplify this further and make it look like the standard normal distribution, I can make what I have in the bracket, which is x minus mu minus so this is 2 sigma square, sorry. It's 2 sigma square times 2 sigma, which is from here. So this is from here. So this is sigma square. This is sigma square. So before I do let, I have to simplify that further. So I have E mu t plus sigma square t square all over 2, 1 all over sigma square root of 2 pi minus infinity, infinity. So this is minus, I want to include the sigma inside the bracket. I will have minus 2 x minus, I'll factor out the square, the power of the sigma, all raised to power 2. So that I can make everything in the bracket to become a letter. So the x, so x minus mu minus sigma squared t over sigma, I can make it to be a letter which is k. Then x minus mu minus sigma squared t will be sigma k. The x will become sigma dk. I'm calling this equation 4. So if I substitute into equation 4, I will have E mu t plus sigma squared t squared all over 2 plus 1 all over sigma square root of 2 pi minus infinity to infinity e raised to power minus half all I have in the bracket. So that's k square times then my dx is changing. Look at my dx is changing to sigma dk. So that becomes sigma dk. So sigma cancel out sigma. What I have is E mu t plus sigma square t square all over 2 plus, no, not plus. Don't have plus here. This is times. There's no plus here. So that should be times. This is like times. There's no plus here. So times minus infinity, infinity. Let me take the 1 over square root of 2 pi inside. If you look at this, fraction, this integral, you'll be able to know the distribution. So that is the f of x, the PDF of a standard number. 1 all over 2 pi e raised to power minus k squared all over 2 is the f of x of a standard number. And remember, whenever you integrate the f of x of a distribution over all the possible values of x, you will get 1. So if this theorem is true, which is always true, so the integral of this standard normal distribution is always 1. So it means this is 1. Let me call this equation 5. Then equation 5 becomes, so from 5, I will have, from equation 5, I will have e raised to power mu t plus sigma squared t squared over 2 times 1, because all this is now 1. All this is now 1. So times 1, so which is e mu t plus sigma squared t squared all over 2. So therefore, the MGF of the normal distribution is e mu t plus sigma square t square all over 2. So this is how to look for the NGF of a normal distribution. If you have any question, you can send to me. You can write it on the comment. If you have any topic you want me to teach, you also write it on the comment. If you have any question you want me to solve, send it to the comments. Like this video, subscribe to this YouTube channel, and share this video. Thank you.